Hey everyone, I kind of forgot about this part of integration. I thought I actually went through it, but I didn't, so my bad. And this part is basically the finding the area with parametric equations. Alright, so I kind of forgot about this, my apologies, and I will go through it now. Okay, so we know what parametric equations are. We have x equals to, let's say, gt, and y equals to ft. Then how do we find the area using parametric equations? Now, it's actually the same equations as using finding area with normal integration, right? So let's say if we have finding that, let's say we have this graph, okay, I'll just draw it better. And let's say if we want to find the area below the graph and the x-axis, we have this area A. If we want to find the area between the graph and the y-axis, then we have the area B. All right, and we know that to find area A, we have integrating whatever value we have. So let's say this is 0 to alpha, and then let's say we have top is 0 to beta. Okay, just so adding limits will be easier for you guys. So to find the area of A, we know that we have 0a alpha. Then let's say this graph has y equals to, let's say hx. Okay, then what we're gonna do is we put in hx inside, and then we solve by integrating with respect to dx. If we want to find the area B, then we will have integrating 0 to beta. Then now we have, well, h inverse y, basically making the x the subject, and then dy. Okay, and if we really rewrite this, what we're going to do is, we know that hx equals to y, so I'm going to rewrite it as 0 to alpha y dx, and for our h inverse y, we know that it's basically x. So x dy. Okay. Now, what do you notice? If we have y, x, and y being defined as gt and ft respectively, we can actually substitute them in, right? So in this case, let's take a look at the one for area A. We know that for area A, we have the limits 0 and alpha, and those are to our x. So what we need to do is, well, firstly, it's just as same as your integration by substitution, because now we are trying to integrate with respect to t. And now we just simply substitute the function first. So with y becoming ft, the limits are alpha and 0. So let's say alpha equals to gt. So upper limit, we then have g inverse alpha equals to t. So our top limit is g inverse alpha. And likewise, our bottom limit is g inverse 0. Okay, now we're integrating with respect to t, so we're putting substitution. That means we have to integrate with respect to t right now, and we need to multiply by the derivative dx dt, which is g prime t. Alright, so it's the same steps as how you integrate with substitution, and basically it's the same idea for parametric equations, just that now we change from integrating with respect to x or y to t now. Same idea for our integrating with respect to dy to find the area B. So once again, find the limits. In this case, the limits are on our y-axis, or rather our y variable. That's why we have f inverse beta and f inverse 0. Then substitute in x, which is gt, then multiply by dy dt, because we're now integrating with respect to t instead of y, and dy dt we know is f prime t. Alright, so this is dy dt, and this is g prime, which is dx dt. Okay, so this is how you find area using parametric equations, both the x and y axis.